So here we have a depiction or an illustration of the Apollo 11 flight path. You see it's leaving the Earth here, does an orbit, and it goes around the moon, lands, then it leaves the moon, does a couple of orbits, comes back to Earth and lands. And here we have a depiction of the moon phases. The moon was in a waxing crescent when Apollo 11 landed on the moon. You can see where the sun is, where the Earth is, and where the moon is. Now we know, according to the heliocentric model, that the sun is going this direction at 45,000 miles per hour, which means that the Earth and the moon are also going that direction at 45,000 miles per hour. But they're also going in an orbit like a corkscrew orbit, according to the heliocentric model. So they never actually go around the moon. The sun, they just go in a little orbit like this. As the sun goes this direction, they follow the sun in like a corkscrew. But they're going 66,000 miles an hour that direction, the moon and the Earth, while they're going 45,000 miles an hour that direction. And that creates a big problem for the heliocentric model, because the spacecraft, the Apollo 11 spacecraft, is going a maximum speed of 24,816 miles per hour, maximum speed. So as it's going 24,816 miles an hour this direction, the moon and the Earth are going straight ahead. You know, the sun basically, in this depiction, or this illustration, the sun will be shining right on this illustration. And so the Earth and the moon would be traveling straight towards the viewer in this illustration at 45,000 miles an hour. This little spacecraft going 24,816 miles per hour would never catch the moon. The moon's going 45,000 miles an hour this direction and 66,000 miles an hour that direction. This thing's never going to catch it. And if it landed on the moon and went back, it's never going to catch the Earth. This thing is just going to be lost in space. If there is space, it's impossible. Now I know what the Globers are thinking, well, it's gravity. It's gravity. That's what it is. Perhaps a Scimandan or DanCantSci, maybe he can explain how this works. Maybe he knows. Maybe he can tell us how this spacecraft going 24,816 miles per hour can catch the moon going 45,000 miles an hour this direction and 66,000 miles an hour that direction. Maybe he can do that. Maybe he'll say it's gravity. So when the spacecraft leaves the Earth, it's basically going 45,000 miles an hour this direction and 66,000 miles an hour that direction and 24,000 miles an hour this direction. So they're all moving together in unison. And that's how it catches the moon. Well, if you're an idiot, maybe you believe that. Maybe you believe that there's some magic force that's making everything continue in one reference frame. And this little ship here is going to go between these objects at just crawling around while these things are flying at 2 and 3 times the speed of this thing. It's impossible. You people need to wake up. This entire scenario is total BS. It's a farce. Nobody landed on the moon. It's impossible. In fact, in the heliocentric model, with all the planets going 45,000 miles an hour this direction, and then their orbits going around the sun, it would be impossible for any spacecraft to go to any planet. There's no rover on the moon, on Mars. You can't get to Mars. you would need a spacecraft that travels at, what, 100,000 miles an hour? Maybe more. Hell, I don't know. You could put an equation to it and come up with the perfect speed. But 24,000 miles an hour ain't going to cut it. And once it's out of the gravitational, the purported gravity, the illusionary magical G, once it's out of that loop, what the hell is it going to do out here? It's a little bitty gnat lost in space. It's impossible. Wake up.